Good morning. My name is Aditya and I'm a computer science PhD candidate at the University of Washington. Today I'm very excited to present BSpeak, which is an accessible, voice-based, phone-based crowdsourcing marketplace for low-income blind people in India. This is joint work with Pooja, Sethi and Richard Anderson. About 90% of the world's 285 million visually impaired people live in low-income settings. India has over 63 million visually impaired people, largest proportionally among all countries, and out of which about 70% people live in rural areas, almost 50% are illiterate, and a vast majority live in severe poverty. Recent years have witnessed the rise of crowdsourcing marketplaces like Amazon Mechanical Turk and Crowdflower that enable people with limited skills to earn money by performing micro tasks such as image tagging, keyword tagging, transcription, and translation. Workers on these services perform these micro tasks at the time and place of their convenience. And as the previous speaker told, there are over 500,000 workers distributed all across the world. And India is the second largest base of Mechanical Turk workers. And MTurk's popularity in India could be easily estimated by the presence of several YouTube videos in different local languages instructing people how to use Mechanical Turk to earn money. Unfortunately, visually impaired people in developing regions like India are often unable to use platforms like Mechanical Turk because of constrained access to internet-connected computer, lack of access to formal banking services, and limited English language skills. Even in the United States, where most of these structural limitations are absent, prior work have reported that blind Mechanical Turk workers face inordinate accessibility and usability barriers such as incomplete task descriptions, inaccessible task features, time restrictions to complete tasks that may yield to poor ratings when the allotted time expires due to an inaccessible feature, and visual captchas in the sign-up and task selection process. In this work, we focus on the assets of low-income, low-literate blind people and explore, can we use smartphones as the device, mobile money as the payment mechanism, and voice as the medium to design a new, accessible micro-tasking platform for them. And with these design constraints, the key question is, what should be a compelling problem that can be divided into voice-based micro-tasks and generate revenues? And this brings us to speech transcription, which is the process of converting an audio content of a file into equivalent textual format. Speech transcription, including general, medical, and legal transcription, is expected to reach $60 billion globally in revenues by the next year. The current solutions, such as manual transcription, or using online services that leverages crowdsourced labor, or submitting of files directly to a speech recognition engine, yield transcription with either poor accuracy or at high cost, or both, for audio files containing local languages and accents spoken in developing regions. For example, the cost of Hindi transcription and Indian English transcription starts at $5 per minute. So in this work, we adapted our prior work on BSpeak to design and build a new platform called BSpeak with two goals. First, to provide additional income generating opportunities to low-income blind people, and second, to facilitate cost-effective and high-accuracy transcription for audio files in local languages and accents. I'll first describe how we designed and built BSpeak. So at the last year's SIGCHI, we presented our work on BSpeak, which is a voice-based crowd-powered speech transcription system where our contributions was conducting cognitive evaluations to refine key aspects of its design and conducting a field deployment with 25 sighted people in India to examine its feasibility to produce high-quality speech transcription. Since the focus of our current study is to provide additional learning opportunities to low-income, low-literate blind people in India, we designed an accessible version of the BSpeak smartphone application called BSpeak using the standard Android accessibility guidelines such as content grouping, providing explicit instructions, and using large touch targets. And our inherent goal here is to investigate how a voice-based, phone-based design could be a usable, accessible, and feasible alternative to systems like Mechanical Turk. Other than making the Android application accessible, we did not make any changes to the underlying system, which I describe next. So the BSpeak system comprises of two entities, the BSpeak engine and the BSpeak smartphone application. To produce transcription and to provide additional learning opportunities to blind people, The BSpeak system uses a 5-step process. In the first step, the BSpeak engine segments a large audio file for transcription into short utterances that are easier for BSpeak users to remember. In the second step, each segment is sent to multiple BSpeak smartphone application users. In the third step, the BSpeak user uses the smartphone application to listen to the segment and repeat the same words back into the application in a quiet environment. The application uses built-in Android speech recognition engine to convert the audio input into a transcript that is read aloud to the user. If the transcript is similar to the audio segment, a user submits it in order to receive a new task. So let's see a demo of how a user completes a task.
Press the play button and listen to the Hindi audio carefully. Max reward 1 rupee. Play button.
भारतीयों की बातें सुनते हैं उनमें से
Press the record button and repeat what you just heard. This will open a Google app for recognizing speech. Record button.
स्वार्थियों की बातें सुनते हैं उनमें से
We recognize this. स्वार्थियों की बात सुनते हैं. Does this closely match with the audio file you heard? No button. Yes button.
So user submits a task when he thinks that the output closely matches with what he heard, and then a new task is loaded onto his app. Now the transcript thus produced is expected to have some errors since a user may not fully understand the audio content, or the speech recognition engine could incorrectly recognize some words, as you see in the demo if you know Hindi. Now to rectify these errors, in the fourth step, for each segment, the BSpeak engine combined multiple users' output transcripts into one best estimation transcript using multiple string alignment and majority voting process. If the errors in the output from speech recognition system are randomly distributed, merging the transcripts from different speakers will improve the overall accuracy if the correct word is recognized for the majority of users. The transcript sent by the user is then compared to the best estimation transcript to determine the user reward based on the overlap between the two. And once the cumulative reward amount earned by a user reaches 10 Indian rupees, a mobile airtime of equivalent value or mobile money transfer is processed on their phone. In the final step, the BSpeak engine combines best estimation transcript for each audio segment into one large file to yield the final transcription. Now to examine if the voice-based and phone-based design of BSpeak could be a better alternative to Mechanical Turk, we conducted a usability evaluation of both BSpeak and MTurk. And since prior work has identified several accessibility issues with how tasks are designed on MTurk, we designed an accessible speech transcription task on MTurk with clear instructions, accessible task features, no time limits, and no captchas. We then conducted a within subject design evaluation where 15 low-income, low-literate blind participants used MTurk and BSpeak in a random order to complete 4 speech transcription tasks and information retrieval tasks. The participants were experienced smartphone and laptop users but had no prior experience both with BSpeak and Mechanical Turk. The annual family income of participants was a modest $4,500 and a majority of them had families living in rural areas. For both systems, we measured task completion rate, task completion time, accessibility score, and usability scores using NASA TLX scale. We also conducted semi-structured interviews. Our mixed methods analysis indicated that compared to Mechanical Turk, BSpeak had significantly higher task completion rate, accessibility score, and performance, and significantly lower completion time, mental demand, effort, and frustration. Despite creating a task with accessible features and clear instructions, participants experienced several accessibility barriers while using Mechanical Turk. A participant articulated many of them. UI elements are not labeled. Navigational and content regions are also not specified. Headings are not structured. H1, H2, H3 should be there, but it starts with H6. Blind people will get confused and say, what is this? I don't think blind people will be able to do work on MTurk. Somehow, I did, but I am not satisfied. Other barriers included lack of structural markups that differentiates between a header cell and data cell in a table, and use of white text on a blue background. MTurk also had several usability barriers, such as overwhelming information on its interface and challenges in going back and forth between listening and typing transcripts. Conversely, almost all participants found BSpeak accessible and usable. They commended its easy to understand layout and found the ability to transcribe audio files by speaking as its key strength. Others also preferred speaking to avoid spelling errors that typing might generate due to constrained space on the phone's keyboard. In summary, enthusiastic responses from participants and strong quantitative and qualitative results in favor of BSpeak prompted us to conduct a deployment in the wild. And we wanted to do so to evaluate its strengths, weaknesses, and feasibility to supplement income of low-income blind people. And with this goal, we deployed BSpeak to 24 blind people in Bangalore, in India, for 2 weeks. A majority of users were male, blind, and almost half of them were unemployed and had families living in rural areas in poverty. We seeded the BSpeak engine with 14 English and 13 Hindi audio files comprising a wide variety of content such as interviews, songs, lectures, speeches, TED Talks. The combined length of these files was 2.75 hours, and the BSpeak engine used the segmentation algorithm to create 2,560 microtasks. The reward amount for each task was a function of its length, and it varied from 60 paise to 1.2 Indian rupees per microtask. During the 2-week deployment, blind users completed over 16,000 tasks to earn over 7,000 Indian rupees. The average speech recognition accuracy was 62%, and the BSpeak engine used multiple string alignment and majority voting process on these transcripts to obtain English transcription with 87% accuracy and Hindi transcription with 92% accuracy. The transcription cost was $1.20 per minute of audio file, 1/4 of the industry standard, and the average amount earned by users was 36 Indian rupees per hour, which is comparable to average hourly wage rate in India. And on an average, users earned 300 Indian rupees, which was enough to subsidize their monthly phone expense in just 2 weeks. And there were several users who earned more than 1,000 Indian rupees in just 2 weeks. In our surveys, we received enthusiastic responses from blind users, perhaps since many of them received an earning opportunity for the first time in their life. A user echoed this sentiment and stated, "I'm grateful to you for creating the app. I earned money for the first time and learned the value of each rupee." Our partner organization, Enable India, also attested to the enthusiastic reception of BSpeak by blind people. And after a week of the deployment, we received the following email from Enable India's management. BSpeak app has become a super hit among our trainees and staff. Most people we have asked love it and also have been making a lot of money through the tasks. We request you to send us a statement that you chose people for deployment based on your criteria and that the organization has shown no favoritism in this. And this was happening because a lot of people were asking to use the app and were questioning why I am the one who is not getting the app to use. BSpeak also provided instrumental benefits to the blind users. They self-reported perceived improvements in their speaking skills, listening skills, and knowledge. Now, since we had access to data about how sighted people used a similar system from our last year's SIGCHI paper, we compared the crowdwork performance of blind users to sighted users on a common set of tasks done by them. And we found that compared to sighted users, blind users completed 3 times more tasks, spent 5 times more time on the app, earned 2.5 times more money in just half the duration, and they performed speech transcription tasks with 10% less accuracy. Although blind users were much more enthusiastic in using BSpeak, disparity in education, socioeconomic status, language skills, and other structural limitations contributed to differences in the accuracy yielded by blind and sighted users. Although there are several interesting research trajectories in this paper and in this work, and for which I request you to read our paper, one of our immediate next step is to improve the payout of BSpeak, since some users expected to earn more money using the application. And there are several interesting and important concrete directions for it, but I highlight only the top 3 of those. First, To improve task completion accuracy, since it directly affects how much users are paid for a task, we observed that several users were using the talkback software at a very high speed, because of which they were not accurately reviewing the transcripts which were generated by the automatic speech recognition engine. And so a concrete step which we are going to take is to either programmatically reduce the playback speed of the talkback software, the screen reader software, or send reminders to the users to reduce the playback speed of the talkback software when they are using the app, so that they can verify their work carefully. Our second step is to decrease task completion time, since it directly affects the number of tasks which can be done in a given time. And we plan to incorporate a feature that automatically skips a task after predefined unsuccessful trials, so that a user does not waste his or her time in doing a task that is too difficult for the user to perform. And finally, since the BSpeak's transcription cost is 1/4 of the industry standard, there is a cushion to increase the task reward by many folds. In conclusion, we contributed to the area of crowdsourcing and accessibility by designing and building BSpeak, an accessible, voice-based, phone-based crowdsourcing marketplace for transcribing speech in local languages and accents. We generated new knowledge about barriers experienced by blind people on MTurk by conducting a usability and accessibility evaluation. We found that despite designing an accessible Mechanical Turk task, participants experienced severe accessibility and usability barriers due to MTurk's own poor and inaccessible implementation. An enthusiastic response on BSpeak during its usability evaluation prompted us to conduct a deployment in the wild, where low-income blind people produced Hindi and Indian English speech transcription at 1/4 of the cost with 90% accuracy and earned 36 Indian rupees per hour, which is comparable to average hourly wage rate in India. We also found that blind users were way more enthusiastic in using the application than the sighted users. Thank you.
Jonathan, Comcast. Hi. When you segment let's say there's a noisy lecture, you segment it, do you shuffle it to different users? Because it seems maybe if one user gets consecutive segments, it'll be easier for them to transcribe because they'll have the context.
Yes. So we actually ran a cognitive evaluation on how it should be presented. Should be like presented in a random order or sequential order. And you're right. Like if we present them in a sequential order, then they are more productive and get more context.
Hi, I'm Sethi Savage from West Virginia University. A great talk. What is your intuition about why sighted users did not prefer this type of tool, maybe for becoming better at audio transcription tasks than the people with the disability?
So I think primary reason is that people who are with visual impairment, they are already using these kind of interfaces to call their friends, to look up information, or to even open the applications. And whereas sighted people are yet to be on board in that capacity compared to blind users, and I guess that's the reason. That doesn't mean that blind users were not enthusiastic about using it, but whatever their enthusiasm level was, whatever the enthusiasm level of sighted users was, blind users were way more enthusiastic than them.